Hello everyone, this is Lisa McClendon, and we're going to tackle percents and percentage points. We use percents to express two different things, or two different concepts, let's put it that way. How much of a whole a part of that whole is, and how much two measures of the same thing differ. I'll give you a couple of examples here. Part of a whole is a tax rate. A sales tax rate is, say, 7% or 8%. That means 8 cents of every dollar is the tax. So that much more is tacked on to your purchase. Groups in a population. What percentage of KU students are in-state versus out-of-state? Score on a test. You guys all know this one. You know if you get a 44 out of 50 on a quiz, that equals 88%. This is your part. This is your whole. Another example of this would be what percentage of KU students are undergraduates versus graduate students. So you have your part, that's this number here. You have your whole, that's this number here. And this is the percentage of the whole that part is. We can also use percents for comparison. Something growing over a time period, tax rate comparison, test score comparison, that sort of thing. Here's an example of that. If we had 26,266 students at KU in 2010 and 25,488 in 2011, it's a decrease because this number is less than this number, so we know that it's gone down, and it's gone down by 2.96%. And we'll talk about how to calculate that number here in just a second. When you're doing the part and the whole, this one's easy. You don't have to do any subtraction. All you do is you take the part, you divide it by the whole, you'll get a number that's a decimal. Something like that. You move that decimal point 2 places to the right, and you get the percent. Here's another example of that. If you had 28,628 students in a school district and 6,724 were Hispanic, how do you find the percentage? Well, you take the part, which is this, you divide it by the whole, which is this, and you get this number. You move your decimal point 2 places to the right, and you get 23.5%. You need an extra step when you're calculating a percent that's a comparison, because you've got two numbers now. You've got 2 points in time, probably something like this. So you have a base number, the one that you're going to measure a percent increase or decrease from. You find the difference. How do you find a difference? You subtract. And you don't have to worry about negative numbers or anything like that, because we know that if something is bigger in 2011 than it was in 2010, it's an increase. And we know that if something is smaller in 2011 than in 2010, it's a decrease. So you don't have to worry about minus numbers or anything like that. Just find the difference through regular subtraction. Take the difference, you divide by your base number, you will get another decimal. You move your decimal point 2 places to the right, and you get your percent. Again, I said if the earlier number is bigger, decrease. If it's smaller, it's an increase. That's common sense. So don't worry about the negatives and the minuses. Just worry about what is the difference and how big a part of the first number is it. Then you'll find out. You can use your common sense then to figure out whether it's an increase or a decrease. Here's another example. Okay, we've got 24,000 students in 2000. We've got 28,000 students in 2007. Okay, we've got two numbers. We've got a change over time. We figure out how much has enrollment increased, and we know it's increased because this number is smaller than this number. Okay, what do we do first? We find the difference. We subtract. Okay, this is our difference. We divide it by the earlier number. We get our decimal here. Move your decimal point 2 places to the right. You get your percent. And we know it's an increase because that first number is smaller than the second number. All right, sometimes you'll hear people talk about percentage points. Percentage points are different. A percent is measuring the fraction of something. A percentage point is how you measure the percent. They're not the same thing. So make sure that if you're comparing percentage rates, you're careful how they're expressed. So we've got an unemployment rate. All right, August 2007, unemployment was 4.1%. Yeah, this was a long time ago. August 2008, it was 5.1%. Okay, how much did the unemployment rate go up? It's very tempting to say it went up 1%, but it didn't. It went up 1 percentage point. It actually went up 24%. And how do you find that? You find the difference, you divide it by your earlier number, you get your decimal, you move your decimal point 2 places to the right, and you get 24%, 24.4. Okay, so there's a big difference between going up 1% and going up 24.4%. Big difference in that, so make sure that you get that straight. Here's another example. If we've got a dropout rate in Andover at 6% and a dropout rate in Newton at 8%, how much more is Newton's rate? Again, it's tempting to say, well, Newton has a dropout rate that's 2% higher than Andover. It's not 2% higher, it's 2 percentage points higher. Again, you find the difference, you divide it by your first number, you get your decimal, move the decimal point 2 places to the right, and you get 33%. So again, 33% is much, much different than 2%. All right, we've got a 2 percentage point difference, but it's actually a 33% difference. And again, take a breath. This isn't complicated math. You learned how to add and subtract. You learned how to multiply and divide when you were in grade school. This isn't calculus. You can do this. You probably did really well in math. So calm down, think about it, do your division, and you'll get your percents.